Imagine, for a moment, that you're sitting under a vast starry sky. Each pinprick of light is billions of years old. And yet here you are, a fleeting speck in an infinite universe. What if your existence is both meaningless and profoundly significant? I'd love to invite you to share in the comments where you're listening from and what time it is. It's fascinating how we're all connected through this shared experience. Consider subscribing to Uncovering Spells so we can keep bringing you reflective narratives. Now, settle in, get comfortable, and let your imagination drift as we delve into the cosmic coincidence. Take a deep breath. Feel the weight of where you sit right now. Whether you're cocooned in blankets late at night or nestled somewhere quiet during the day, pause for just a second to think about this. Every molecule in your body, every atom that makes up the air you breathe, was forged in the heart of dying stars. You are literally made of stardust. And yet, despite being part of something so ancient and grand, you're also impossibly small compared to the scale of the cosmos. This duality, this strange tension between insignificance and significance, is what we call the cosmic coincidence. To truly grasp the improbability of our existence, let's zoom out to the very beginning of everything. Around 8 billion years ago, the universe exploded into being in what we now call the Big Bang. In those first moments, the fundamental forces of nature were set in motion. Gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces didn't just shape galaxies and stars. They determined whether life itself could ever emerge. Here's the thing. These forces had to be fine-tuned to an almost incomprehensible degree. If gravity were even slightly stronger, the universe would have collapsed back on itself before anything interesting could happen. If electromagnetism were weaker, atoms might never have bonded to form molecules. Scientists estimate that the odds of such precise conditions aligning by chance are astronomically low. One physicist famously likened it to winning a lottery with odds of 1 in 10 to the power of 229. To put that number into perspective, there are only about 10 to the power of 80 atoms in the observable universe. Winning this cosmic lottery feels less like luck and more like some kind of miracle. And yet, here we are. Humanity exists against these astronomical odds, perched precariously on a pale blue dot orbiting an average star in a nondescript galaxy. We are simultaneously insignificant, tiny specks adrift in an indifferent cosmos, and miraculous products of unimaginable precision. It's enough to make your head spin. So what does this mean for us? Does the sheer unlikelihood of our existence give life inherent meaning, or does it highlight its absurdity? This question has haunted philosophers, scientists, and poets for centuries. On one hand, the universe doesn't seem to care about us. Stars burn out, planets crumble, and entire civilizations vanish without a trace. From this perspective, human life appears fleeting and inconsequential. But on the other hand, isn't it remarkable that we exist at all? That consciousness, a phenomenon still not fully understood, emerged from mere matter? Doesn't that suggest a kind of beauty, a spark of something extraordinary amidst the chaos? This paradox lies at the heart of the cosmic coincidence, meaning it seems is not something the universe provides. Rather, it's something we create. Perhaps the act of finding purpose within an indifferent cosmos is itself a testament to human resilience and creativity. Or maybe the lack of inherent meaning frees us to define our own paths, unburdened by external expectations. Either way, the tension between insignificance and significance invites reflection. Paradox of free will. Is every choice you've ever made truly yours, or were they predetermined long before you were born? Take a deep breath. Feel the weight of that question. This is where philosophy meets neuroscience, and things start to get strange. Let's linger here for a moment. Imagine standing at a crossroads, faced with two paths. You choose one, perhaps because it feels right, perhaps out of habit, or maybe even randomly. But was that decision really yours? Or was it shaped by countless factors beyond your control? Your upbringing, your biology, the cultural context in which you exist? What if, on some level, the outcome was already written into the fabric of reality? Free will is one of those concepts that seems intuitive until you start pulling at its threads. On the surface, it appears obvious. We make choices every day, don't we? Yet, as we peel back the layers, cracks begin to form in this seemingly solid foundation. To explore this paradox, we must first understand what free will means and why it matters so much to our sense of self. At its core, free will refers to the ability to act freely, without external constraints dictating our actions. It's the belief that we are the authors of our own lives, capable of shaping our destinies through conscious decisions. Philosophers have debated this idea for millennia, dividing themselves into two main camps: determinists and libertarians. Not political libertarians, but philosophical ones. Determinists argue that everything, from a movement of planets to the firing of neurons in your brain, is governed by cause and effect relationships. If we could know all the variables influencing a situation, they claim, we could predict any outcome with perfect accuracy. In this view, free will is an illusion. Our choices are simply the inevitable result of prior conditions. Think of it like dominoes falling. One event leads inexorably to the next, leaving no room for deviation. Libertarians, on the other hand, insist that humans possess genuine autonomy. They argue that while physical laws govern the material world, consciousness introduces an element of unpredictability, a ghost in the machine, that allows us to transcend pure determinism. According to this perspective, when you stand at that metaphorical crossroads, your decision is genuinely yours, unfettered by preordained forces. Modern neuroscience adds another wrinkle to this debate. Studies using fMRI scans have shown that brain activity associated with making a decision often begins several seconds before we become consciously aware of having made it. This suggests that our brains may decide for us before we think we've decided. Does this mean free will is merely a post hoc rationalization of unconscious processes? Or does it leave space for a more nuanced understanding of agency? The implications of this paradox are profound. If free will is an illusion, then moral responsibility becomes murky. How can we hold someone accountable for their actions if they had no real choice in the matter? Conversely, if free will exists, how do we reconcile it with the deterministic nature of physics? Quantum mechanics introduces yet another layer of complexity. Randomness at the subatomic level challenges classical notions of causality, suggesting that unpredictability might be baked into the universe itself. This tension between order and chaos mirrors the broader theme of tonight's exploration. Just as the cosmos operates under laws both rigid and mysterious, so too does human behavior straddle the line between inevitability and spontaneity. Perhaps the answer lies not in choosing sides, but in embracing ambiguity. The possibility that free will isn't entirely real, nor entirely fake, but something fluid and context-dependent. Consider this. Even if our choices are influenced by factors outside our control, doesn't the act of deliberation still carry meaning? Isn't there value in striving to shape our lives, regardless of ultimate outcomes? These questions don't demand definitive answers. Instead, they invite us to sit with uncertainty and find beauty in the process of questioning itself. If free will remains uncertain, perhaps another layer of reality holds answers or more questions. Let's shift gears and explore a theory that blurs the boundaries between science fiction and metaphysics. The idea that we might be living inside someone else's dream or simulation. Could the very fabric of existence be artificially constructed? Join me as we dive into the simulation hypothesis. Before we proceed, take a moment to reflect on the interplay between fate and freedom. Close your eyes, breathe deeply, and imagine yourself at that crossroads again. Who or what is guiding your steps? The journey ahead promises to unravel even deeper mysteries. The simulation hypothesis: what if everything around you, the stars, the trees, even your own thoughts, is just code running on a supercomputer? It sounds like science fiction, but some very smart people think it could be true. Pause for a moment and consider this. When you play a video game, the characters within it experience their world as real. They navigate landscapes, interact with objects, and make decisions based on the rules of their simulated environment. To them, their reality feels tangible, even though it's entirely constructed by lines of code written by someone outside their universe. Now, imagine if our lives are not so different from those characters. What if we're living inside a simulation, unaware of the programmers who designed us, or the machine powering our existence? This isn't just idle speculation. It's a hypothesis that has gained traction among philosophers, physicists, and technologists alike. Let's explore how such an idea came to be taken seriously and what it might mean for our understanding of reality. The simulation hypothesis was popularized by philosopher Nick Bostrom in his seminal paper, "Are You Living in a Computer Simulation?" Bostrom proposed a trilemma, arguing that one of three possibilities must be true. Civilizations never reach the technological capability to create realistic simulations. Perhaps advanced civilizations destroy themselves before achieving this level of sophistication, or they choose not to pursue it due to ethical concerns. Advanced civilizations do develop the ability to create simulations, but opt not to run them. Maybe simulating conscious beings raises moral dilemmas too complex to justify. We are almost certainly living in a simulation. If countless simulations exist, the probability that any given consciousness resides in the base reality diminishes dramatically. Bostrom's argument hinges on the assumption that future civilizations would have both the computational power and motivation to simulate entire universes, perhaps billions of them. With enough processing capacity, these simulations could replicate every detail of human experience, including emotions, memories, and sensory perceptions. From the perspective of someone inside the simulation, there would be no way to tell the difference between their artificial reality and what we perceive as real life. To illustrate this concept, consider modern technology. Today, we can create hyper-realistic virtual environments using VR headsets and sophisticated algorithms. While these systems are far from perfect, they hint at the potential for indistinguishable simulations in the future. If progress continues exponentially, why wouldn't a sufficiently advanced civilization achieve something akin to full immersion? The implications of the simulation hypothesis are staggering. First, it challenges our most fundamental assumptions about reality. If everything is simulated, then concepts like matter, time, and space lose their objective status. They become constructs designed to mimic a coherent universe. Even consciousness itself might be artificially generated, raising questions about whether self-awareness requires a biological substrate or simply the right programming. Second, the hypothesis forces us to reconsider our place in the cosmos. In traditional cosmology, humans occupy a tiny corner of a vast, indifferent universe. But in a simulated framework, we might represent the central focus of the simulation, a kind of experiment or entertainment devised by higher intelligences. Alternatively, we could be incidental artifacts, mere background noise in a larger project whose purpose eludes us. Perhaps the most unsettling aspect of the simulation hypothesis is its epistemological uncertainty. If we can't trust our senses to distinguish between simulation and reality, then how can we know anything at all? This echoes René Descartes' famous dictum, "I think, therefore I am." Even if everything else is an illusion, the act of doubting confirms the existence of the doubter. Yet, in a simulated world, even that certainty might be programmed. Despite, or perhaps because of, these mind-bending possibilities, many find comfort in the hypothesis. After all, if we're living in a simulation, it implies a creator with intent, however inscrutable. For some, this offers a strange kind of solace. The notion that our struggles, joys, and sorrows serve a greater purpose, even if we'll never fully understand it. Whether real or simulated, the universe has its secrets. One of the biggest mysteries lies right above us. Why haven't we found anyone else out there? As we leave behind the digital realm of simulations, let's turn our gaze skyward. The silence of the cosmos is deafening, especially given the sheer number of stars and planets scattered across the galaxy. Why does it seem like we're alone? Or are we simply missing the signs? Join me as we delve into the Fermi Paradox. Take a moment to reflect on the possibility of being part of a grand experiment. Feel the weight of knowing or not knowing that your reality may be engineered. Breathe deeply and let the vastness of the unknown envelop you. The next segment promises to unravel yet another enigma of existence. The Fermi Paradox. There are billions of galaxies, each containing billions of stars, and yet no clear evidence of alien civilizations. Why is the cosmos so eerily silent? Close your eyes for a moment and imagine the night sky. Stretching infinitely above you is a tapestry of stars, countless suns scattered across an incomprehensible expanse. Each one has the potential to host planets, some of which might harbor life. And yet, despite decades of searching, humanity has found no definitive proof that we're not alone in the universe. This silence, the absence of detectable extraterrestrial intelligence, is what scientists call the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" This paradox challenges our understanding of life, technology, and the nature of existence itself. As we explore this mystery, let's consider why its implications are both humbling and haunting. To grasp the Fermi Paradox, we first need to understand just how vast the universe truly is. There are approximately 100 billion galaxies in the observable universe, and each galaxy contains roughly 100 billion stars. Many of these stars have planetary systems, with estimates suggesting there could be trillions of Earth-like planets capable of supporting life. Given such staggering numbers, it seems almost inevitable that intelligent civilizations should exist elsewhere. Yet, when we look outward, all we hear is silence. No radio signals, no interstellar probes, no signs of advanced technology or communication. Why? Scientists have proposed numerous theories to explain this discrepancy, ranging from the optimistic to the deeply unsettling. One possibility is the rare Earth hypothesis, which suggests that while microbial life may be common, intelligent life is exceedingly rare. According to this view, Earth's unique combination of factors, its stable orbit, plate tectonics, magnetic field, and large moon, created conditions necessary for complex organisms to evolve. If even one of these variables were slightly different, life as we know it might never have emerged. Another explanation is the Great Filter, a hypothetical barrier that prevents most civilizations from reaching technological maturity. The Great Filter could occur at any stage of development. Perhaps life struggles to get started, or maybe intelligent species inevitably destroy themselves through war, environmental collapse, or artificial intelligence gone rogue. If the Great Filter lies ahead of us, humanity's future becomes precarious. If it lies behind us, we may indeed be among the few survivors in a mostly barren cosmos. Other theories lean toward more speculative territory. Some suggest that alien civilizations deliberately avoid contact, either out of caution, the zoo hypothesis, or because they've transcended physical form altogether. Others propose that we simply lack the tools to recognize their presence, They may communicate in ways beyond our comprehension, or their activities might blend seamlessly into natural phenomena. The Fermi Paradox raises profound existential questions. If intelligent life is exceedingly rare, does that make humanity special or tragically isolated? Does the silence of the stars imply that civilizations tend to self-destruct before achieving interstellar communication? Or could it be that life follows a cyclical pattern, emerging and fading without ever encountering others? These uncertainties highlight the fragility of existence. On one hand, the possibility that we're alone underscores the preciousness of life on Earth. Every act of creation, every connection between individuals, takes on added significance when viewed against the backdrop of cosmic emptiness. On the other hand, the thought of being surrounded by unseen neighbors who may choose not to engage with us can feel profoundly alienating. Moreover, the Fermi Paradox invites reflection on humanity's role in the universe. Are we destined to remain confined to our pale blue dot? Or will we someday join the ranks of star-faring civilizations? If we do venture outward, will we find ruins of failed experiments or thriving societies eager to share knowledge? Ultimately, the paradox reminds us that curiosity is a defining feature of human consciousness. Even in the face of ambiguity, we persist in asking questions, seeking patterns, and yearning for connection. Perhaps the act of wondering itself is enough to imbue our lives with meaning. As we ponder the silence of space, let's turn inward to something equally mysterious: the enigma of consciousness itself. While the Fermi Paradox challenges us to confront the vastness of the external universe, the next segment dives deep into the internal cosmos of the mind. How does matter give rise to thought? What is the essence of awareness, and why does it feel so uniquely human? Join me as we unravel the hard problem of consciousness. Before moving forward, take a moment to sit with the stillness of the cosmos. Imagine the quiet stretch of space between stars, the infinite possibilities hidden within that void. Breathe deeply and allow yourself to marvel at the mysteries that lie both outside and within us. The journey ahead promises to illuminate one of the greatest riddles of all: the nature of subjective experience. The hard problem of consciousness. How does a lump of gray matter produce the vivid tapestry of your subjective experience? This is the hard problem of consciousness, a riddle that keeps philosophers and scientists awake at night. Pause for a moment and focus on your immediate surroundings. Notice the soft hum of the air, the gentle rhythm of your breath, or the faint glow of light filtering through your eyelids if they're closed. These sensations, mundane as they may seem, are extraordinary when you stop to think about them. How does a 3-pound organ inside your skull generate this rich inner world, complete with colors, sounds, emotions, and thoughts? Why does it feel like something to be you? This question, the hard problem of consciousness, is what separates neuroscience from philosophy. While science can map brain activity and explain how neurons fire, it struggles to account for the qualitative essence of experience, often referred to as qualia. Tonight, we'll explore why consciousness remains one of humanity's greatest unsolved mysteries, and what its persistence tells us about our place in the universe. To understand the challenge posed by the hard problem, let's first distinguish it from the so-called easy problems of consciousness. The easy problems involve explaining measurable functions of the brain: how sensory input is processed, how memories are stored, how motor commands are executed. Though far from trivial, these tasks fall squarely within the realm of scientific investigation. The hard problem, however, goes deeper. It asks why physical processes in the brain give rise to an inner life: the feeling of seeing red, hearing music, or tasting chocolate. Why should neural circuits produce not just behavior, but also subjective awareness? And why does this awareness feel unified, coherent, and uniquely personal? Philosopher David Chalmers coined the term hard problem in the 1990s to emphasize the gap between objective phenomena, like brain scans, and subjective experience, like the taste of coffee. He argued that no amount of neuroscientific data can fully bridge this divide because qualia resist reduction to physical terms. Consider an analogy. Imagine trying to describe the color blue to someone who has been blind since birth. No matter how precisely you define wavelengths of light or retinal receptors, you cannot convey the ineffable quality of blueness, the way it feels to see it. Similarly, even the most advanced brain imaging technology cannot capture the lived experience of being conscious. The hard problem raises profound questions about the nature of reality. If consciousness arises from purely material processes, then why does it feel so different from other physical systems? A computer performs calculations without experiencing anything. Why should the human brain be any different? Some theorists propose panpsychism, the idea that consciousness is a fundamental property of the universe, akin to mass or charge. In this view, all matter possesses some degree of awareness, though only certain configurations, like brains, yield complex experiences. Others advocate for dualism, suggesting that mind and body are distinct entities interacting in ways we don't yet understand. Still others argue for emergentism, positing that consciousness arises spontaneously when systems reach sufficient complexity. Each theory comes with its own set of challenges. Panpsychism risks anthropomorphizing inanimate objects, while dualism struggles to explain how immaterial minds interact with physical bodies. Emergentism, meanwhile, leaves open the question of why consciousness emerges at all, and whether machines could achieve it someday. These debates highlight the limits of human understanding. Despite centuries of inquiry, we remain strangers to our own minds. Yet, paradoxically, this ignorance underscores the wonder of existence. Every thought, emotion, and perception reminds us that we are more than mere biological machines. We are participants in a mystery that transcends explanation. Consciousness may remain elusive, but another profound mystery looms large. What happens when nothingness becomes everything? As we leave behind the labyrinth of the mind, let's journey back to the beginning, to the moment before time, space, and matter existed. From a void came everything we know, including ourselves. How did such creation occur? And what does it reveal about the nature of reality? Join me as we explore the Big Bang and absolute nothingness. Take a moment to reflect on the miracle of awareness. Feel the weight of being present, of existing as both observer and participant in the unfolding drama of life. Breathe deeply and allow yourself to marvel at the fact that you can think about thinking at all. The next segment promises to take us to the very edge of existence itself. The Big Bang and absolute nothingness. Before the Big Bang, there was nothing. No space, no time, no laws of physics. But somehow, from this void, everything emerged. How is that possible? Pause for a moment and try to imagine nothing. Not empty space, not darkness, but the complete absence of anything. No dimensions, no particles, no forces, no framework for existence itself. This is what physicists refer to as absolute nothingness. And yet, out of this absolute void came the universe we inhabit today, a cosmos teeming with galaxies, stars, planets, and life. The story of the Big Bang, the explosive birth of our universe, is one of science's greatest triumphs. It describes how all matter, energy, space, and time sprang into being approximately 8 billion years ago. But the deeper question remains, why did something come from nothing? What caused the transition from non-existence to existence? As we delve into this mystery, prepare to confront the boundaries of human comprehension and perhaps glimpse the handiwork of creation itself. To understand the origins of the universe, let's first clarify what scientists mean by the Big Bang. Contrary to popular misconceptions, the Big Bang wasn't an explosion in space. It was the sudden expansion of space itself. In the earliest moments, the entire universe was compressed into an infinitesimally small point known as a singularity, where the laws of physics, as we know them, break down. What lies beyond the singularity? That's where things get tricky. Some theories suggest that before the Big Bang, there was truly nothing, not even the potential for something. Others propose that the universe arose from quantum fluctuations in a pre-existing vacuum, a realm governed by the strange rules of quantum mechanics. According to these models, particles can spontaneously pop into existence due to inherent uncertainty in the fabric of reality. When applied to the scale of the cosmos, such fluctuations might have triggered the emergence of our universe. One compelling explanation comes from physicist Lawrence Krauss, who argues that nothing isn't stable. Even in the absence of matter and energy, quantum fields can generate temporary disturbances, creating virtual particles that flicker in and out of existence. Over vast time scales, these fluctuations could accumulate enough energy to spark a new universe. In this view, the Big Bang may have been inevitable, a natural consequence of the underlying principles of physics. Another intriguing idea is the concept of multiverses. If our universe is just one bubble in a larger cosmic froth, then the Big Bang might represent the collision or splitting of universes within a grander multiverse. While speculative, this theory suggests that creation is an ongoing process, with countless realities branching off continuously. The implications of the Big Bang and absolute nothingness are both awe-inspiring and humbling. On one hand, the fact that something exists at all defies logical intuition. Why should there be anything rather than nothing? Philosophers have wrestled with this question for millennia, often concluding that existence itself is fundamentally mysterious. On the other hand, the possibility that the universe arose naturally from quantum randomness or multiversal dynamics challenges traditional notions of divine intervention. Does this diminish the wonder of creation, or does it amplify it? After all, if the cosmos bootstrapped itself into being without external guidance, doesn't that make its complexity even more remarkable? Moreover, the Big Bang reminds us of humanity's fleeting place in the grand narrative of existence. Our planet, our species, and even our individual lives occupy just a sliver of cosmic history. Yet, within this brief span, we've managed to piece together fragments of the universe's origin story, a testament to the power of curiosity and imagination. At the same time, the Big Bang leaves room for existential reflection. If everything began from nothing, will it someday return to nothing? Will entropy eventually erode all structure, leaving behind only cold emptiness? Or does the cycle of creation and destruction repeat endlessly, ensuring that existence persists in some form forever? These questions don't demand answers. They invite contemplation. They remind us that while science provides tools to explore the unknown, it cannot quench the human thirst for meaning. Perhaps the true significance of the Big Bang lies not in its mechanics, but in its invitation to marvel at the sheer improbability of being. From the origins of the universe, let's move to its potential end. Could entropy be the ultimate arbiter of meaning? As we leave behind the fiery birth of the cosmos, let's turn our gaze toward its distant future, a fate shaped by the relentless march of disorder. What happens when stars burn out, black holes evaporate, and the universe descends into eternal darkness? Join me as we explore the heat death of the universe. The heat death of the universe. In trillions of years, the stars will burn out, black holes will evaporate, and the universe will descend into eternal darkness. Is this inevitable decay the final word on existence? Pause for a moment and let that sink in. Imagine a universe devoid of light, movement, or life. A cold, silent void stretching endlessly in every direction. This is the predicted outcome of the cosmos as described by the theory of heat death, also known as thermodynamic equilibrium. It's a sobering vision, one that forces us to confront the impermanence of all things. Yet, within this bleak forecast lies an opportunity to reflect on what gives meaning to our fleeting lives. As we explore the mechanics of heat death and its implications, let's consider not only the science behind it, but also how such a destiny shapes our understanding of existence. The concept of heat death stems from the second law of thermodynamics, which states that entropy, or disorder, always increases over time in any closed system. Entropy measures the amount of energy unavailable for work. As it rises, systems lose their ability to sustain organized structures like stars, planets, and living organisms. Here's how it unfolds. In the distant future, stars will exhaust their nuclear fuel and cease to shine. Galaxies will grow dim as stellar remnants cool into dark, lifeless husks. Over unimaginable timescales, even black holes, the densest objects in the universe, will slowly evaporate through a process called Hawking radiation, leaving behind nothing but diffuse particles drifting aimlessly through space. Eventually, the universe will reach a state of maximum entropy, where all energy is evenly distributed and no gradients remain to drive change. Without differences in temperature, pressure, or density, there can be no flow of energy, and thus no possibility for complexity, structure, or life. This is the heat death of the universe, a condition of perfect equilibrium, where nothing happens because everything has already happened. To illustrate this idea, think of a cup of hot coffee left on a table. Initially, heat flows from the coffee into the surrounding air until both reach the same temperature. At that point, no further exchange occurs. The system has reached equilibrium. Now scale this up to cosmic proportions, and you begin to grasp the inevitability of heat death. The prospect of heat death raises profound existential questions. If the universe is destined to wind down into inert uniformity, does that render our efforts meaningless? Does the knowledge of ultimate decay diminish the value of creation, love, art, and discovery? Or does it heighten their significance precisely because they are temporary? Philosophers and theologians have long grappled with the tension between permanence and impermanence. Some argue that meaning must transcend mortality, that without eternity, nothing truly matters. Others contend that impermanence is what makes moments precious. Like a flower blooming briefly in spring, the transient nature of existence lends it beauty and urgency. From a scientific perspective, heat death underscores the fragility of order in the universe. Life itself depends on localized decreases in entropy. Think of how your body maintains structure despite the chaotic tendencies of molecules around you. Yet, these pockets of order are exceptions to the rule, sustained only temporarily before succumbing to the pull of entropy. Interestingly, the inevitability of heat death doesn't negate hope. Instead, it invites us to focus on the present, to cherish the warmth of connection, the brilliance of ideas, and the wonder of being alive right now. Perhaps the purpose of existence isn't to escape entropy, but to create something meaningful within its constraints. Even in the face of cosmic oblivion, humans have always sought patterns and connections. Let's now dive into the labyrinthine world of fractals. While heat death paints a picture of ultimate dissolution, the next segment explores a counterpoint: the persistence of order amidst chaos. Fractals reveal a hidden harmony in randomness, reminding us that even in decay, there is beauty. Join me as we unravel fractals and infinite complexity. Take a moment to sit with the weight of eternity. Feel the contrast between the vast emptiness of the future and the vibrant immediacy of the present. Breathe deeply and allow yourself to marvel at the paradox of impermanence and infinity. The next segment promises to illuminate the intricate designs woven into the fabric of reality. Fractals and infinite complexity. Fractals reveal a hidden order in chaos, patterns that repeat infinitely, no matter how closely you look. They remind us that even in randomness, there is structure. Pause for a moment and imagine holding a snowflake in your hand. Each delicate branch splits into smaller branches, which split again into tinier filigrees, creating a design so intricate it seems almost otherworldly. Yet, this complexity arises from simple rules repeated endlessly. This is the essence of fractals, self-similarity at every scale, where the whole mirrors its parts in an infinite dance of recursion. As we explore the mathematics and philosophy of fractals, let's consider how these patterns echo the duality of simplicity and complexity, not just in nature, but also in human existence. Fractals are geometric shapes that exhibit self-similarity across scales. Unlike traditional Euclidean shapes like circles or squares, fractals have fractional dimensions. They exist somewhere between one-dimensional lines and two-dimensional planes. One of the most famous examples is the Mandelbrot set, a mathematical construct that produces stunningly intricate images when visualized. Zooming into the boundary of the Mandelbrot set reveals endless layers of detail, each as complex as the last. Nature is full of fractal-like structures. Consider the branching of trees, the veins of leaves, the meandering paths of rivers, or the spirals of seashells. These forms arise because they optimize efficiency, whether it's maximizing sunlight absorption, minimizing energy expenditure, or distributing resources evenly. Fractals demonstrate that simplicity can generate immense complexity through repetition and iteration. Mathematically, fractals emerge from recursive processes. Take the Koch snowflake, for example. Start with an equilateral triangle, then repeatedly add smaller triangles to each side. With each iteration, the perimeter grows longer while the area approaches a finite limit. This interplay between boundedness and infinity captures the paradoxical nature of fractals. They are both contained and limitless. The implications of fractals extend far beyond geometry. They challenge our intuitions about order and chaos, revealing that apparent randomness often conceals underlying patterns. For instance, coastlines appear jagged and irregular, yet their fractal properties allow scientists to measure them more accurately. Similarly, clouds, mountains, and galaxies, all seemingly chaotic systems, can be described using fractal principles. On a philosophical level, fractals invite reflection on the relationship between simplicity and complexity in life. Much like the iterative processes that create fractals, human experiences often unfold through cycles of repetition and variation. Daily routines, relationships, and personal growth all involve recurring themes that evolve over time. Even history itself seems to follow fractal-like patterns, with civilizations rising and falling in ways that echo past epochs. Fractals also raise questions about infinity and perception. If a shape contains infinite detail, does it exist fully only in theory, or can we experience it meaningfully? The act of zooming into a fractal mirrors the human tendency to seek deeper understanding, to probe beneath the surface of things in search of truth. But what happens when we reach the limits of resolution? Do we find clarity, or do we discover new mysteries waiting to be unraveled? Moreover, fractals remind us of interconnectedness. Just as the smallest part of a fractal reflects the whole, individual actions ripple outward to affect larger systems. A single choice, no matter how small, contributes to the unfolding pattern of existence. In this way, fractals offer a metaphor for finding significance in insignificance, a reminder that even the tiniest details matter in the grand tapestry of life. Fractals teach us about repetition and infinity. Now let's shift focus to the fleeting nature of individual moments and the concept of impermanence. While fractals highlight enduring patterns, the next segment turns our attention to the transient and ephemeral. Life unfolds in a continuous flow of change, where nothing remains static, not even time itself. How does the passage of moments shape our sense of reality? Join me as we explore impermanence and the flow of time. Take a moment to reflect on the interplay between constancy and change. Close your eyes, breathe deeply, and notice the rhythm of your thoughts as they drift by like leaves on a stream. Breathe in the eternal. Breathe out the now. The next segment promises to illuminate the delicate balance between permanence and flux, impermanence and the flow of time. Time flows relentlessly forward, carrying us away from the past and toward an uncertain future. Yet without change, would anything truly exist? Pause for a moment and feel the weight of this present instant, the quiet hum of existence before it slips into memory. Everything around you, the air you breathe, the thoughts in your mind, the very cells in your body, is in constant motion, shaped by the ceaseless current of time. Nothing stays the same, not even for a second. This is impermanence, the fundamental truth that all things are transient, fleeting, and ephemeral. As we delve into the nature of time and its implications, let's consider how impermanence defines our lives, and whether embracing this reality can help us find meaning amidst the flux. To understand impermanence, we must first grapple with the nature of time itself. In physics, time is often treated as a dimension akin to space, a measurable quantity that moves uniformly forward. But human experience tells a different story. For us, time feels fluid, subjective, and deeply personal. A joyful moment may seem fleeting, while a period of hardship can stretch endlessly. Philosophers have long debated the essence of time. Heraclitus famously declared, "You cannot step into the same river twice," emphasizing that change is the only constant. The river's water flows continuously, altering its composition with each passing second. Similarly, our lives are rivers of moments, never repeating exactly as they were. In contrast, Einstein's theory of relativity introduced the concept of the block universe, where past, present, and future coexist simultaneously. From this perspective, time isn't a flowing river, but a frozen landscape, with every event already etched into the fabric of space-time. If true, this raises questions about free will and the illusion of movement. Could our sense of progression through time be merely a trick of consciousness? Consider, too, the paradoxical beauty of endings. Just as winter gives way to spring, death paves the path for renewal. Without loss, there would be no room for growth. Without darkness, no appreciation for light. Impermanence reminds us that endings are not failures. They are integral parts of cycles that sustain life. As we reflect on the passage of time, let's conclude with a synthesis of opposites, embracing both the emptiness and fullness of existence. Having explored the relentless march of time and the fragility of moments, we now arrive at the culmination of tonight's journey. How do we reconcile the tension between emptiness and abundance, insignificance and significance, nothingness and everything? Join me as we delve into emptiness and fullness. Take a moment to sit with the flow of time. Feel the gentle pull of the past receding and the unknown promise of the future approaching. Breathe deeply and allow yourself to rest in the eternal now, the only place where life truly unfolds. The final segment promises to weave together the threads of our exploration, offering a harmonious resolution to the paradoxes of existence. Regardless of which view resonates more deeply, both perspectives highlight the inevitability of change. Whether time flows or exists as a static whole, the contents of our lives are perpetually shifting. People grow older, seasons cycle, civilizations rise and fall, all proof that nothing endures forever. The impermanence of all things has profound implications for how we live and find meaning. On one hand, the transient nature of existence can evoke feelings of loss, anxiety, or futility. If everything fades, what's the point of striving, loving, or creating? Why invest energy in pursuits that will inevitably vanish? On the other hand, impermanence underscores the preciousness of the present moment. Because nothing lasts, each experience becomes uniquely valuable, a gift to be savored rather than taken for granted. Mindfulness practices, rooted in Buddhist philosophy, teach us to embrace impermanence by focusing on the here and now. By accepting change as natural and inevitable, we can cultivate gratitude for what is, rather than clinging to what was or fearing what might come. Impermanence also challenges us to redefine success and fulfillment. Instead of seeking permanence, a futile endeavor, we can aim to contribute to the ongoing flow of life. Acts of kindness, creativity, and connection leave ripples that extend beyond our lifetimes, shaping the world in ways we may never fully see. In this way, impermanence invites us to participate actively in the unfolding story of existence. Emptiness and fullness. In Zen Buddhism, emptiness isn't absence, it's potential. Perhaps the key to reconciling nothing matters with everything does lies in this paradoxical truth. Pause for a moment and let that idea settle within you. Imagine standing in a vast, open field at dawn. The sky still dark, the air crisp with possibility. There is nothing tangible before you, yet the emptiness brims with promise. It is a canvas waiting for brushstrokes, a symphony awaiting its first note. This is the essence of emptiness, not a void of despair, but a space pregnant with infinite potential. As we bring our journey to a close, let's explore how embracing both emptiness and fullness can help us navigate the contradictions of existence. By holding these opposites together, we may discover a deeper harmony that transcends dualities and find peace in the paradoxes of life. The concept of emptiness, or sunyata, originates from Buddhist philosophy and offers a profound reframe of reality. At first glance, emptiness might seem synonymous with meaninglessness, a bleak acknowledgement that nothing has inherent substance or permanence. However, sunyata teaches something far more nuanced, that all phenomena are interdependent and lack independent, fixed essences. Consider a flower. Its beauty doesn't arise in isolation. It depends on sunlight, soil, water, pollinators, and countless other factors. Strip away any one of these elements, and the flower ceases to exist as we know it. In this sense, the flower is empty of self-nature. It is defined entirely by its relationships. Yet, this emptiness is precisely what allows the flower to bloom, to participate in the intricate web of existence. This principle applies to human life as well. We often search for meaning in external achievements, identities, or possessions, believing they will anchor us against the tides of impermanence. But true fulfillment comes not from clinging to fixed notions of self or purpose. It arises from recognizing our interconnectedness and embracing the fluidity of being. Fullness, then, emerges from emptiness. When we release attachment to rigid definitions of who we are or what life should be, we open ourselves to the richness of experience. The emptier the vessel, the more it can hold. The synthesis of emptiness and fullness provides a framework for understanding the overarching theme of tonight's exploration: why nothing matters and everything does. On one hand, the universe operates according to laws indifferent to human concerns. Stars explode, galaxies collide, and entropy marches forward without regard for individual lives. From this perspective, our struggles and triumphs appear insignificant against the backdrop of cosmic scale. On the other hand, the very act of existing, of participating in the unfolding drama of creation, is an extraordinary gift. Every breath, every heartbeat, every shared laugh or tear contributes to the tapestry of existence. Meaning isn't something handed down from above. It's something we create through connection, compassion, and presence. This duality invites us to adopt a posture of humility and wonder. Humility because we are small, temporary, and deeply embedded in systems larger than ourselves. Wonder because even in our smallness, we carry the spark of consciousness, a capacity to reflect on the mystery of being and to shape the world around us. As we draw this journey to a close, take a deep breath and feel the weight of where you sit right now. Whether you're cocooned in blankets late at night or nestled somewhere quiet during the day, remember that you're a part of something impossibly vast and wonderfully intricate. Tonight, we've traveled from the origins of the cosmos to the mysteries of consciousness, from the inevitability of heat-death to the infinite complexity of fractals. Along the way, we've grappled with some of humanity's most profound questions and perhaps found solace in their unanswered depths. Thank you for joining me on this exploration of paradoxes and possibilities. Wherever you are and whatever time it is, I hope you carry with you a renewed appreciation for the fleeting yet eternal nature of existence. Good night and sweet dreams.